Hello everyone, our topic is stock prediction using multi-mixture models. In today's financial market, there's great benefit under the vast information but also more competition. In this environment, deep learning networks, which may take the best use of the data, are coming to the stage. Currently, there are two genres of financial models. Machine learning models like boosting tree, random forest, and hidden Markov can have better speed and interpretation, while deep learning like RNN and attention models could take accuracy to an extreme. But now the thing is there always a trade-off between agile and accurate? They are both really important. A slight improvement means much more revenue, while some model predictions must be done in seconds or even milliseconds. So our main idea is that can we have a model with both best accuracy and simplicity in most of the cases? It turns out that mixture models can have amazing results, which we'll talk later.
Our dataset is from the Kaggle competition held by Ubiquint Investment Company. There are more than 3 million training data, includes one target variable, which is the investment return rate, two identifiers, time ID and the investment ID, and also 300 features that are used to predict investment returns. Here is the overview of our dataset. The mean of target variable is nearly 0 and the standard deviation is close to 1. We could reasonably assume that the data has been regularized. As for the identifier, each investment has balanced amount of data, even though a small fraction of time has less data. Our features are 300 alpha factors, which are anonymized by the company due to some confidential concerns. Then the problem is, what are alpha factors? They are all kinds of complex transformations of fundamental economic-wide variables. An easier way to interpret is that they are a set of variables highly related to economic factors and can be used to capture risks that affect asset returns.
Here's the result of our model. We built a simple trading strategy based on the prediction of our model. And as we can see here, out of all the deep learning-based models, returns of our model is the highest, but it still did not beat the turtle strategy, which is a traditional and popular trading strategy. So beside the mixed model, we also tried the encoder of the transformer sequence to sequence, and the last model we implemented in our homework, and our baseline model. So this is a transformer sequence-to-sequence model we used. For the input, we use the previous 30 days alpha factors as input and to predict the t+1 days return. This is the encoder of transformer we used. So different from sequence-to-sequence model, we use the encoder of the transformer to predict the current time step return based on the current time step alpha features. We first compute the embeddings of the alpha factors, match the alpha factors to different time steps, and predict the same time step return. So this is the last model. For this model, we use the same input as the transformers. We use the previous 30 days alpha factors as input to predict the t+1 days return.
Right now, let me propose our mixed model here. It contains 3 attention CNN models, 3 CNNs models, and 3 MLPs model. Each models share the same structure but different parameters. Finally, we take the average output as our prediction. Here is our result. For our core evaluation criteria, Pearson correlation, our mixed models is the baseline model and other comparison models. We also compare different models with other evaluation parameters such as RMSE, RMAE, MAPE, and we got the result here. From the result, we can get an idea that our mixed model better than our baseline in different evaluation. Right now, let me talk about our research story. We start with transformer and attention, but it doesn't work, so we go back to our baseline MLP, 1D CNN, and our CNN and attention. Later, we find out that mixed MLP is better, so we came out with an idea that we can mix the models periods to get a better result. We get these two conclusions. First, mixed model have better performance in predict stock market data. Second, mixed different models have better performance than mix only one structure. Thank you for watching.